everyone, today we will be talking about linear regression. So let's say you have a bunch of data and you want to find patterns in that data. For example, here's a graph of the annual ppm or carbon dioxide levels, and we might be interested to learn from the past how these trends have been going and try to use that to predict the future. And that's exactly what linear regression tries to do. You're taking some data to learn a function, which we call f, so that then you can provide it unseen data, which we call input, and still get a nice and good output. Now, there are multiple things we can change in this setup. For example, how do we even learn this function from the data? That's what we call a learning algorithm. And second, what types of functions can we even learn? We call them predictors, and the types of predictors we can have are all classified within a hypothesis class. And finally, we need to have some way of determining how good our predictor is. I mean, even if it spit out a lot of numbers, is that even a useful number to keep? And that's what we call a loss function. So the loss function will help us determine what predictors are good, and that might also help us maybe tune our learning algorithm. So coming back to this example, we might want to fit this line. And here, the function would just be a linear function. Here, we can then kind of generalize this format where we're saying, okay, m and b from the traditional linear line, we'll call them w1 and w2 to say these are our weights or parameters that we want to learn. And then we can say, okay, we want to have a function that can combine our w1 and w2, so our m and b, with the data that we are seeing, for example, the x value. And then we'll try and find a way to see how good or bad this line is. And to do so, we can measure the distance between each point to the line that we are predicting. So on the left, we can see a line that's pretty well aligned with all our data points because the distances between each point in the line is quite small. And then on the right, we can see a line that doesn't really fit the data that well, which means that the lines between the data points and the predicted line are a lot larger. So in this case, we could say, okay, the line on the left is actually better than the line on the right. Now to see this in action, I built this little demo right here. So if we go here, we have our linear feature vector. And what does that mean? That just means that in our example here, we're going to multiply by a constant and just our variable x, our data point. And then we define our two w's, which are our weight vectors. And then we're going to multiply them together to get our line. So for example here, we have our data points. And now the task for the learning algorithm is to try and find the best settings, the best parameters, w1 and w2, to try and fit these data points. And we can see that if I, for example, slide this w right here, we can see that the line is going up and down. And what we can see is that we're now computing the squared loss. So what this means is that we're taking each distance from the data point to the line, squaring it, summing it up, and that's what we're getting here for the loss. And if we keep on trying a bit more, we might be able to find kind of a sweet spot where our loss goes down quite a lot. And here we can see that we're finding a line that pretty well fits our data. However, this can become quite tedious to do manually, which is why we want a way to automatically do this learning process. And this would also allow us to have many more features. Not only x and not only just x, we can maybe have x squared, we can have a bunch of more variables, and we don't have to be constrained to just the x. We might have multiple variables. We might have, the year, but we might also have temperature and humidity, all these variables that we might want to model. So in this case, we need a way to automatically learn this relationship. And that's what we can use this training loss and take its gradient. So the gradient is kind of saying where on this loss do we have the greatest ascent. It's like going through a mountain valley, and let's say you want to climb a mountain. If you want to climb the mountain the fastest, you probably want to take the path that's steepest, because if you take a lot of steps in the steepest direction, you're going to quite quickly rise to the top. But in this case, we want to get the loss to be as low as possible. And this is why we're trying to subtract the gradient of the training loss. And then we have this parameter called step size, which is going to say how quickly we're going to take these steps. And here we can see a visualization of using these points right here, where we start with just 2 0 values, but because this is not really a good line, we're quickly going to try and shift the line until we find a line that's pretty well suited for the data. And what we can do is we can try and change this. So for example, this 0 3 point or 1 3 point here, I might change that to be a 7. And I might change this point right over here to be also up a little bit. So we might have -1 and 7. And then maybe this point is going to be -4 and 10. And let's see, maybe we have another point here. So now we would expect the training algorithm to get a different line. And also, as we can see, it's kind of getting there, but here it's moving the line up, but because the step size is quite small, it might not have time to rise. So in this case, we might have had to run the algorithm a few more times to get the line, or have a bigger step size so we would find this line even faster. And what's really nice about the linear regression is that we're not limited to just a line. We can actually throw in a lot of different functions, like x squared, which allows us to even have polynomials. We might even have cosines to get periodicity in our data. So for example, if I just add in another weight and then this x squared term, what we can see is that we can now start to model these polynomial relationships. And now, instead of tweaking just 2 parameters, each time we're running the learning algorithm, we would actually be tweaking 3 parameters, trying to find a line that is better suited to the data. All right, so that's a brief introduction to linear regression. Thank you so much for watching, and see you in the next video. Bye.